All right, guys. So today we're going to talk about chemical symbols versus chemical formulas. So if you haven't and you would like to print off this sheet, you can right now. It is going to be attached as a PDF. So you can just click on it and hit print if you have a printer and be able to follow along with me. I'm going to have some different colors just so you all can see the different things and it makes it kind of more fun. But you don't have to have different colors. You can just have a pen or a pencil. And hopefully this won't take too long. We're just talking about how elements and how compounds are represented. So on Monday and Tuesday, you talked about elements and compounds. Hopefully you remember the difference between those. All right. And today we're going to talk about how they're represented so you don't have to write out a whole bunch of stuff. Okay? All right, so let's get started. So a chemical symbol represents an element. And hopefully you remember and you can already kind of know what a chemical symbol is because we've done a lot of stuff with chemical symbols. You should have heard that word. You should remember that it was on the element tile that we talked about last week. Okay? So chemical symbol represents elements, and they're represented by one or two letters. They're also found on the periodic table of elements. So if you're wondering what the chemical symbol for boron is, you can just look straight at the periodic table of elements and look at the element names, and you can find boron and see that it's just a capitalized B. So if you look at the periodic table of elements, sometimes there are one letter, sometimes there are two letters for the chemical symbols. Okay, so a chemical symbol always has to contain an uppercase letter, and it could contain one lowercase letter. Okay, so let's talk about some examples. So my first example is going to be lithium. This is a metal that's found on the left-hand side of the periodic table if you're looking for it. And it is represented, its chemical symbol is big L, little I. Okay, notice I made it a big L and a little I. So that is the correct way to write it. I'm going to put a little check mark next to it. Okay, my next example that I'm going to write is one that hopefully you've seen a whole bunch of times, and it's the big C. Hopefully you know what that means already. Maybe you started to memorize some of them, but that is carbon. So we've talked a lot about carbon, and actually carbon makes up a huge amount of our universe and our bodies. We'll talk more about that later. Okay? So that's carbon. And my last chemical symbol example I'm going to show you is sodium. So once again, if you want to try to see if you remember sodium, or you can look it up, the chemical symbol for sodium is big N. Notice I'm using a big N, okay, and a little a. Now you might be wondering, why did they use Na for sodium? If you can, look it up and see if you can tell me why sodium they use Na for that one. It's kind of weird. None of those letters are in sodium, right? So again, I used a big N. You always capitalize the first letter, and a small a. Okay, don't capitalize the second letter if there is a second letter. Okay, so now let's show some non-examples. Are you ready? So magnesium is another metal that is on the left-hand side. And a way that you wouldn't write magnesium, it's Mg. So I might see someone write little m, little g. Nope, that's wrong. Hopefully, in your head, you're thinking, I got to capitalize that M. Okay? All right, what about chlorine? So chlorine is big C, and I've seen people write big L. That's chlorine. So think, what is wrong about that one? Because we know these are all non-examples, so they're not correct. Hopefully, you're seeing this L, which should be lowercase. Okay? What about, how about beryllium? That's a funny word. Kind of looks like berry, but it's beryllium. Okay? I've seen people write small b, big E. Nope, they didn't get either of those letters right? The E or the B should be big B, and the E should be small. Okay, now let's do one more. So what about if you just have one letter? So hydrogen only has one letter, it's an H. Do you have to capitalize it? Hopefully in your head you're saying yes, but I've seen people write it with just a little h. No, you gotta capitalize that H. Okay? So make sure that you see the difference between these examples that are good, woo, and these non-examples that are bad. Okay? So always capitalize the first letter, have the lowercase letter be second. All right? Okay, so that's your chemical symbols. Hopefully you kind of remember them, you started to see them. Now the thing that we need to talk about that's new is our chemical formula. Okay, so yesterday you talked with Miss Wyndham, and on Monday you talked with Miss Wyndham about compounds versus elements. So elements, that is, here, let me just add a little note. So it's one type of atom only. Okay, so it only has one type of atom. Chemical formulas represent compounds. And compounds have more than one type of atom bonded together. Okay? So, a chemical formula is going to be representing a compound. Okay? So, if you have carbon and hydrogen and oxygen all together, it's really difficult to have to write all of that out over and over and over again if you have to keep writing them, right? So, scientists figured out a way to create a representation or to shorten how much you have to say. Okay? And a chemical formula has to contain the chemical symbols of each of the elements present, okay? And it has to show how many atoms of each element are represented, and that's by a subscript. So subscript is a new word, but hopefully this little drawing down here can explain what a subscript is. Okay, so if you think submarine, it's underneath the water. Okay, so the subscripts are the small number under the chemical symbol. Okay, and I'm even going to box all of these subscripts down here, and we'll talk more about them in a minute, okay? But a subscript, that's what a subscript is, okay? It's a small number underneath the chemical symbol, okay? So don't put it up at the top like you're doing exponents. That's not the same. It won't tell you the right thing. All right, let's do an example before we talk about the submarine and maybe color that in and do all those different things, okay? So my example is going to be for this one that you should know really well. Hopefully you already know it, okay? Let me get my mouse out of here so you don't have to look at my mouse all the time. But it has hydrogen. Remember, I have to have the big H. And it has a subscript of 2. So notice it's beneath the H. And then I also have an O. O for oxygen. Okay? So hopefully you can recognize H2O, which is water. Whoop whoop. Just water. Okay? So for this, to be able to figure out how many atoms and what type of atoms there are in this chemical formula right here, okay, what we need to do is we need to first figure out what this H means, and hopefully you know, but you can look on your periodic table, and that is hydrogen. So I'm going to write hydrogen over here. And we also have an O, which hopefully you know you can recognize as oxygen. So we have hydrogen and we have oxygen. Okay, those two go together. So a lot of ways to figure out if it's a chemical symbol or a chemical formula is to look on your periodic table of elements, and if there aren't those letters together, that means that they are separate, two different chemical symbols that have come together and are bonded chemically. Okay? But now we need to figure out how many of the hydrogen and how many of the oxygen. So if I'm going to do that, I need to look at my subscripts. Woo, subscripts. Okay, and a subscript goes with the letter to its left. Okay, so that 2 doesn't go to the O, it goes to the H. All right, so there are 2 atoms of hydrogen. Okay, let's look. Well, I look at my O for oxygen, and there's nothing down there. There's no subscript for it. Really, that's not true. There is a subscript, but the subscript we don't have to write over and over and over again because it's just a little invisible 1. So a little invisible 1, let's make that look like a 1 and not an L or something. But that 1, which is invisible, because you don't want to have to keep writing over and over and over again that 1 when you know if it's on there, there's only 1 of it. That goes with the oxygen. Okay, so there's 1 oxygen atom. Okay? So actually, 3 atoms make up H2O. And I'll even draw it for you over here. So there's 1 oxygen atom, and it is bonded to 2 hydrogens. So 2 hydrogens, 1, 2, 1 oxygen atom. All right? That's water for us. All right, let's look at this one down here. So you can color in, you can do a bunch of stuff with this if you'd like to. I might color in a little bit of the submarine. Right? I might color in my crab. It's over here. But that's something that we can do after, okay? So this chemical formula right here contains 3 different chemical symbols. It has C, it has H, and it has O. Hopefully you're starting to notice that we are talking about the same ones over and over again. So the C represents carbon, the H hydrogen, the O oxygen. And this symbol right here is actually the symbol for sugar. Woo! This is sugar. That whole thing. Okay? So it tells us it's C6H12O6. That's how you say it. Okay? So you don't say CHO6126. You say C6H12O6. Okay? So that is the chemical formula for sugar. And down here we need to fill in some stuff. So it says there are blank carbon atoms in glucose, which is the same thing as sugar. So I'm going to write sugar down here too. It's just a type of sugar. It's the table salt. It's the table sugar that we use. Okay? So we need to look at carbon. First, we need to think about what is the chemical symbol for carbon. That's that big C. Okay? And remember, when we look at subscripts, the 6 goes with the letter to its left. Okay, so I'm going to draw a little arrow. So there are 6 carbon atoms in glucose. Now it asks us, there are blank hydrogen atoms. Okay, hydrogen I know is big H. Where's my big H? It's right there, okay? And that 12 is attached to and goes with the letter to its left. So there are 12 hydrogen atoms, okay? And last but not least is this O. There are blank oxygen atoms. So hopefully what you have left fits with that O, and it does. Oxygen's chemical symbol is O, okay? And it has a 6 attached to it. So again, there are 6 oxygen atoms, okay? So if the easiest way to remember and see if it's a chemical symbol or a chemical formula is to notice if it has 2 capitalized letters, okay? If it has more than 2. If it only has 1 capitalized letter, then that's just going to be a chemical symbol. If it has multiple, like this one has 3 capitalized letters and this one has 2 capitalized letters, then that means that it's going to be a chemical formula because there's more than one type of atom. Okay? All right. Hopefully you all are trying to understand this. If you need to go back and try again, do so. Otherwise, let us know if you have questions. I'm excited to see you soon.